Hi, welcome to this video. It's for Leetcode 92 reverse linked list. So this question falls under the umbrella of how to reverse a linked list in place, and it follows kind of the same idea that you have when you want to reverse a linked list by itself. So forgot to write that down. Technique is linked list reversal. Let's take a look at what we have here. So there are actually two different ways you can do this problem, and we're going to take a quick look at both of them. So let me hide the Leetcode. So alright, so one way you can think about this is that you have a linked list where you have, let's say, 1, 2, 3, 4, 5, 6, 7. And in this Leetcode question, they give it to you like, oh, n is 3, and then n is, let's say, 6, okay? So this just means that you want from the third one to the sixth one inclusive, and you want to just reverse that. So your final list will look like 1, 2, 6, 5, 4, 3, 7, where the reversed part is here. So as I mentioned, there are two ways to do this, and so the solution given to you on Leetcode will cover that right after this, but somebody on YouTube named Leet Tuition came up with this solution that I really liked as well. So imagine that you have your original linked list, and what you want to do is always keep a pointer at the position right before where you have to switch. Remember we said n equals 3, right? So that would be the third node, but you want to keep track of the previous, which in this case is 2. And so what you do is you also keep track of like we'll call that C for now, current. So you always want to take you always start reversing where C is, okay? So let me actually erase some of that, get in the way. So P is right here, C is right here. So your goal is to take the node to the right of C, which we'll call next, and constantly put it right after P. So what you see that if you move 4, you end up with 1, 2, 4, 3, 5, so on. And when you get to step 2, what you want to do is, you remember where C is, and you remember where N would be because it's just next, but you never move P. So now the same idea persists. You take N and you move it right after P. And if you do that, you see that 5 becomes right there, okay? So same idea. C stays with that node, N becomes 6, P doesn't move, and what you want to do is you take N and move it directly after P. And when we say move, what we really mean is I'm going to take P and I'm going to have it point to 6, right? So it's a P dot next becomes whatever N is. And we said because current is at 3, N is at 6, okay? So that's one way to do it. I think if you take a quick look at the code that goes with that, basically you have an anchor. So anchor in this case, I guess we could call it like the previous, right? That's just, and then you can have, so anchor is the start of the original list, and then you have before the start of the reverse, which was previous for us, and then start of the reverse, which would be C, right? So if you, this is just the code that does that, and you see that if you have a linked list here, that's the P that we had, and that's the current, and next is obviously right here to the 4. And you see that you have these things just moving over. That's all. That's all they're doing. You have these arrows, right? So you take next, which is 4. You have it be pointed to by the pre, number 2. Meanwhile, current continues on, right? Because 4 got moved. So then current will be 5 at the next step. And we'll step through this really quickly right after we talk about the solution that Leetcode gives you. So the solution that Leetcode gives you is very similar to the original reverse linked list. So the original reverse linked list basically is like, okay, I take one node. So originally maybe it was like, just say A, B, C, pointed to like to the right. And then the solution would be, okay, well, let me save a pre, and then start saving temp next, and then, you point B backwards, you point A backwards, and then you move A to where temp is, okay? So that's how you reverse a regular linked list in place. Now, in this example, we have m equals 2, n equals 4, so you're going from the second node right here to the 4th node inclusive, right? This is where you want to be reversing. So what's another way to do it compared to the solution offered last time? Well, what you do is you figure out your starting point, right? You also need to remember the place that you were before you started. You have to remember that at some point you have to link up to this, the rest of it, right? So you focus on here. Basically, you have to iterate through the linked list until you get to the starting point. Do the thing that we talked about previously, where you had a previous, and then you have the start point to previous, and you start reversing them one by one. Okay. And so we can go through this really fast. And what you do next is you look at what your variables are when you first start. So we said you had to iterate through where you would begin. So you get the, what is they say, count, right? Count is, at this point, count is going to be 2. Okay, you see count is 2. And so temp next is going to be null, right? Because we're just starting. And then current next, it's technically going to be something we don't know yet because we're just getting there. And then previous, which we don't have yet, so it's going to be null. And current right here is going to be head. Okay, oh, previous, here's null. So that's where you are right now, right before you get into the while loop right here. So once you step into the while loop, what you're going to have is the previous values of temp next and previous and head. I put all those there. So we know that current is this, right? And so temp next becomes right here. It was null before, now it becomes 30. Current.next, well, current.next, we know that in the in place reversal, you just point it backwards, right? And it's going to be null, right? So current.next is going to be null. And then previous ends up being what current is, which is at 20. And then you move current forward to 30. All right? And all that, you know, is very kind of straightforward if you look at the code here. So the next step right? So we set temp next to the current dot next. So this is current at 30. So this becomes temp next. And then the current dot next is previous. So current dot next is going to point backwards, right? Because this is previous. And now you're at the previous, it's going to move up. So you're going to move up previous to here. Then you're going to move up current. So you cross that out. Current becomes temp next, right? 30 becomes 40. And then once you do that, you end up here. And when you end up with current at 40, temp next, right? Temp next, right here on this line, it becomes 5. And that's super important because if you look at the Leetcode solution on Leetcode, they tell you that at some point you have to be able to have a pointer next to this particular node so that you can connect it. Because when you finish what you're doing in this particular while loop right here, you end up with this thing. And then you have to manually say, oh, okay, well, then 1 needs to point to 40, right? And 20 needs to point to 5. Because it's over here, all I did was change the direction of the arrows, okay? I didn't actually redraw them. Because if you redraw them, obviously you have 1, 40, 30, 20, 5, 6, and 7, and everything pointing to the right. So that's what will happen if you go through that different way. So let's do a really quick run through of the code of what you get when you go through the solution that the YouTube user Leettuition gives us. Let me try to get rid of these things. And all right, so we need to see the code. Okay, so some of this is a little bit marked over. So we'll just say m equals 2, n equals 4. So that we know, hey, we're just doing from the second node right here to the fourth node right here, inclusive. Now, let's see. The original arrows that you see all point from left to right. And so if you follow the code, what you see is that basically you have a dummy pre, which is very similar to when you reverse a linked list. And then here you step through until you get to M. Then the meat of the code basically starts here. So current is pre.next, because pre, we see pre has settled at number 1, okay? So pre.next will be cur right here. So we see pre starts at 1, cur starts at 2, next obviously starts at 3. All right, so on this line, next equals current.next, which we have right here, okay? Then we have cur.next equals next.next. So we have cur.next equals next.next. So 2 points to 4. That's very important. 2 is pointing to 4. Okay? Now, next.next equals pre.next. So, next is right here. Its .next is pre.next. Well, what is pre's next? Next.next. Well, right now, pre's next is current. It's number 2. This basically means move next to point to the right, the same thing that's being pointed to by pre, right? That's how you know that you can move this third node into this spot right here. So you have number 3 pointing to number 2, right? Number 3 pointing to number 2. And then at the end, your last step, pre.next, which is right here, points to next, which is 3. Pre.next, point to next. All right. Some of that is a little confusing, but if you remember just really quickly, the idea is that you have a current and you take the node to the right of current and place it right after pre. Okay? Place it right after pre. So basically it becomes 1, 3, 2, 4, 5. Or if you want to think about it like with the arrows, it's 1, 3, 2, 3 points to 2, and 2 points to 5. Okay? So let's see what you do on the next step, because I redid the arrows here, but slightly confusing. Let's go to the next step. All right, so I already drew some of the arrows here. You have pre, which never moves, cur, which is technically the same node, just kind of in a different spot, right? So when you start this stage, pre is still 1, cur is still the second node, number 2, and next is 4, okay? So what's happening right now? Well, what's happening right now is next becomes current.next, okay? Well, that becomes 5, because right now next is 4, next, oh, sorry, next, yeah, next is current.next, and current is 2, sorry. And then current.next is next.next. So current.next is next.next. So 2 is going to point to 5. Okay. And then what you want to do is next.next is pre.next. So next.next equals pre.next. Next we know is at 4. 4 is going to point to 3. okay? Because right now 1 is pointed at 3, and you want to effectively move 1 to this spot, okay? Then pre.next equals next. So pre.next 1 is going to end up pointing to 4, okay? So what do you have right now? So you have right down here, 1 points to 4, 4 points to 3, 3 points to 2, and 2 points to 5. 2 points to 5 is right here. This is the cur.next equals next.next. And because you start with m equals 2, n equals 4, you're only going to run through this twice. Okay? So, oops. Those are the new arrows that you have. And then if you look at what you have at the very end, if you leave everything in place, that's where you have the top one. If you move the nodes, that's what you see at the bottom. Because 1 points to 4, and then 4 itself goes backwards. And then 2 points to whatever 4 had. So that is it. Kind of as before, there are 2 solutions to Leetcode number 92. If you want, you can have an in-place reversal by keeping track of, let's say, the starting point and the ending point. You know, doing your in-place reversal, then connecting. Or the second way is, as we mentioned, you can keep track of the place right before you start reversal and keep track of a current and constantly move the node to the right of current to be directly to come next of P. Okay, so those are the 2 different ways that you can do this. I will link to the code for both solutions, both Leettuition's code and also the one that you would find easily on Leetcode, and I will comment it completely so it's easier to understand. Okay, thank you for listening.